This one, for warm up here, I think we could factor it. Yeah, it can't. It won't factor nice. I won't get, I'll get an x minus 12 when I factor out the x squared. When I take the, what would come out of there, 16 out of there, I wouldn't get an x minus 12. So let's go ahead and put in our calculator. Okay. So we do our y equals, we graph it. It's x cubed, right?
Yeah.
Minus 12x squared plus 48x minus 64. And it's bending as it crosses. So what's that telling me? 3 times at least, right? Odd multiplicity. Again, some of you, I don't think, understand what I mean by multiplicity. Multiplicity just means that that 0 works more than one time. Okay? And if it bends like this one does as it crosses, that means it has odd multiplicity of at least 3. And since my degree of this polynomial is 3, this number, which looks like 1, 2, 3, 4, looks like that would, there's only 1 0, but it's going to work 3 times. Okay, so that's all multiplicity means. How many times does it work as a 0? Okay, so some of you are just writing odd or even multiplicity for that answer. I want how many times it actually works. So if it's even, it's probably 2, maybe 4. If it's odd, it's probably 3. I don't think we've had much bigger than a 6, right? Next to the 6 was the biggest I think we've had. Okay, but I'm going to go to my table to make sure that it's a 4 that I'm thinking. Okay, remember, table is second graph. And I got to go down to the 4, see what's going on here. Okay, so that's correct. From the table, I can see that my 0 is 4. Remember, we're looking for the y being 0, but the 0 is actually the x value, all right? Remember, when the y is 0, that's on the x-axis. That's what the zeros are, where the graph crosses the x-axis. All right? And since it's bending as it's crossing, it should work 3 times. So I'm going to check to make sure by doing what? Synthetic division, yes. Okay? So I'll put my 4 over here in my corner. And I got a 3, a 2, a 1, and the constant. So I don't have to add any zeros, but that's what you should check, just like we did before. So a 1, it's negative 12. Some of us are missing that sign when we do these. And a negative 64. Okay, remember, you're dropping the 1 below the line. Some of us are going 4 times 1 and putting the 4 under the 1 and going from there. Okay, drop that first one below the line and go 4 times 1, and that goes under the second number. Okay, and then we add them, which is negative 8. 4 times negative 8 is negative 32, and that's a positive 16, and 4 times 16 is 64. And I get that 0, what I'm supposed to get, right? If it's a 0, when you do synthetic division, you get a 0 where the remainder is, okay? That means that x minus 4 is going to be a factor of that polynomial, okay? And then you just do it again because it's supposed to work more than once, okay? So let's make sure that's happening. 4 times 1 is 4. When I add those, I get negative 4. 4 times negative 4 is negative 16. And there's, it worked again. I got that 0. And then you do it one more time because we're thinking 3 times. 4 times 1 is 4. And in fact, it does work 3 times. So you can write multiplicity of 3, or if you just want to put a 3x for 3 times beside it, you just told me it has a multiplicity of 3, meaning it works 3 times. Okay? If I asked you to factor this then, all right, when I know what the 0 is, the factor is always x minus whatever the 0 is. And then since it worked 3 times, it would be to the 3rd power. So if I did that problem, multiplied that by itself 3 times, I would end up with this original polynomial. Is that making sense to you guys? Does anybody have a question on that? Connor?
So when you're, how do you know how many times it's supposed to be multiplied by 0? Is it like the amount of times that you can do the synthetic division? Or
Yes.
Something in the problem?
Yeah.
Okay.
All right, and I know that it should happen because when I watched it, it was bending as it crossed. If it would have went just straight through as it's crossing, it's only going to work 1 time. If it bounces off the 4, it's going to work at least 2 times. It's going to have even multiplicity. Anita, did you have a question?
Yeah, on the quiz, will we have to write it in like the factor?
No, not now, but we're going to get to this part, maybe next week or the week after. So just kind of let you know what's going on there. Holly? It's second graph. Well, anybody else have a calculator issue? Just making sure you're coming back to me. You and Maddie are struggling right now. Because stay up too late last time? All right, any other questions on that? Oh, Sam,
What would be for 3 times
what do you mean 3
For
times?
Because you said like when it bounces, it'd be 2 times and straight through.
Right, it bends. As it crosses, it's gonna work at least 3 times like this did.
Oh, okay.
Okay? So you gotta pay attention as you, when you hit it and watch it, see what it's doing. If it's straight through, it usually goes really quick. Okay? It goes kind of a little bit slower if it's bending. And then if it bounces, sometimes it bounces real quick. But as you watch it on your screen.
So would there be one for like 4 times now or no?
Well, it could be a 4-time one, could be a bouncing one, because that's even. So it could be 2 or 4 or 6.
Okay.
All right. But when you look at this degree here, that's how many zeros it's going to have. Okay. Now these, all 3 of these were real zeros. Sometimes you can't see all the zeros. Sometimes they're non-real, the imaginary ones. And I think the first one of your homework practice quiz was one of those. Okay, maybe that was what your question was. Okay, so we'll look at those. All right. So number 1 for the practice quiz. If there's no other questions on that warm up. We've got x to the 4. So how many zeros am I going to try to find? 4 of them, right? Okay. And when we look at this graph, we'll only be able to see 2 of them. Again, you don't know that beforehand. I just know it because I've done it already. Okay? But again, that's tough to factor, so let's not worry about factoring it. Let's just put it in our calculator in our y equals. All right, so x to the 4th minus x to the 3rd plus 19 x squared minus 25x minus 150. Alright, again, I punch it in, but I always check to make sure I punched it in right. Because if you don't do this part right, then you're gonna be wrong, right? So make sure you do that, so take your time to do that. Okay, then hit graph. Now you gotta watch it, see what happens here. Okay? Go straight through, straight through. Because see how fast it went? Usually when it goes fast like that, it's straight through. Even though you see like a little jog there, that's just the pixels. You know, some of you have a newer one. You can tell a little better. Some of yours is colored, different colors. All right, that looks like a -2 and a +3. Okay, but I'm going to check to make sure. I'm going to go to my table, second graph. There's the -2, there's the +3. Okay. A little bigger. Okay, so -2, +3. Now, if it bounced off of both, that would be 2 and 2, there would be my 4, right? But since they went straight through, they only work one time. Okay? So to figure out the other two, I have to do this synthetic division with -2 and 3, and I will reduce this polynomial, right? It's starting out as x to the 4th. So if I do synthetic division twice, after I do it twice, it'll reduce it to an x squared, a quadratic. Then I'll solve that quadratic, either by using the quadratic formula, or if b is 0, which it is in this one, you can just do it without the quadratic formula. Okay? So, let's move this over. Okay. Give me some room. All right, so it doesn't matter which one you start with. Okay, I usually just go left to right, but it doesn't matter if you start with the 3 or the -2. Okay, so I'm going to start with the -2. 4, 3, 2, 1, constant, so I don't need to add any zeros. So I got a +1, a -1, 19, -25, -150. Again, those signs are important. You forget those signs, which some of you did on the quiz last week. It makes a difference, okay? Remember, we dropped the 1 below. -2 times 1, and then -1 plus -2. -2 times -3. Positive, add, +25. -2 times 25 is a positive, or -50. -25 and -50 is -75. And a negative times a negative is a positive. And I get my 0. So it worked. And that's what I'm supposed to get, right? If I don't get that 0, check your work. Because you did something wrong. All right, then I do the 3. Again, you don't rewrite it. You just go by what's down here. Okay, just put it right beside there. And then go again. 3 times 1 is 3. I get 0. 3 times 0 is 0. I get 25. And 3 times 25 is 75. I got my 0. Okay? So, about half the time, you'll get a 0 here. You don't need to use quadratic formula. That's your A, that's your B, that's your C with the quadratic formula. Because that was 1x to the 4th. After I do it once, that's 1x cubed. After I do it the second time, that's 1x squared. So this problem right here is 1x squared plus 0x plus 25 equals 0. Well, I don't need to worry about that. Okay? So basically, this x squared plus 25 is 0. Okay? So we're going to take the 25 over. x squared equals negative 25. So, what's the step now? To get x. Square root, right? So here's where that imaginary one comes. Since my number over here is negative, I got to pull the I out, remember? So this answer is x equals, remember, plus or minus, when we do that, square root both sides. 25 square root is 5, but since it's negative, I. So that's why we couldn't see the other two on the calculator, because those are imaginary zeros. And that gives us our 4. Our answers are 0, negative 2, positive 3, negative 5i, and positive 5i. Okay? We really hadn't gotten to any of those in our homework, but you might see one like that tomorrow on the quiz, okay? Any questions on that? So if you can't see all of them, remember, it started out as x to the 4. You're looking for 4 of them. You only saw 2 of them. Use synthetic division to reduce it down, and then reduce it down and then solve that quadratic. Okay? Again, if you want to use the quadratic formula, you can. I'll write it down for you again. You guys should know this though. Let's do it this way. Negative b plus or minus. Morning, Z.
Morning.
You do your practice quick?
Nope.
Slacker.
That was fine.
Well, I'm glad you got a little extra sleep then. You're okay now, right? Okay, if you want to use, the quadratic formula, you can. Right, Mason? You don't have to. Okay? Questions on that one? Connor, I'm going to take that phone from you. And I'm going to give you a bone saw.
Oh.
Okay. All right, number 2. How many zeros again? 4. Now this one, I think will factor. Okay, so I'll go ahead and factor just to do one that way. The GCF is x squared. And then I'll get x squared minus 3x minus 3. And that won't factor, will it? There's no factors of negative 3 that give me negative 3 when I add. The only way to get negative 3 is 1 times negative 3 or negative 1 times positive 3. And both of those will give me a positive 2 or negative 2. Okay? But since I got the GCF of x squared, what do I do to get x? Square root. So I get x is plus or minus 0. There's 2 zeros, so that's 2 times. When you look at the graph, what's it going to do at 0? Since it's twice, it works. Bounces, yeah. Now, to find this one, the other 2, I can use the quadratic formula, right? So this one I'm doing without even using the calculator. But if you use the calculator, that's fine. That's okay. All right? So I'm going to use the quadratic formula. So negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right, just since we haven't done this for a while, that's why I was going to show you this. Positive 3, 2, and then square root. So that's a 9. Negative 3 squared. Negative 4 times 1 is negative 4 times negative 3 is a positive 12. 9 and 12 would be 21. Okay? So there's the other two. If you did it in your calculator, all right, 3 plus the square root of 21 divided by 2 is 3.79 or 3.8. So your calculator will give you the 3.8. That's okay with me. And then do the minus. Oops. Negative 0.79 or negative 0.8. If you use your calculator, got those two decimals, I will accept that. So 0 works twice, so make sure you tell me it's multiplicity. There's the third one, 3.8, and the fourth one, negative 0.8. If you did it this way and left it in radical form, that's okay with me. The 21 won't reduce, when you do a factor tree for that. Questions? That one makes sense? So I did that all by hand. I factored out the GCF, and then I couldn't factor that anymore, but it's a quadratic, so I used the quadratic formula. But it's okay, again, to use your calculator if you want. And remember, when you look at your calculator, the graph, it's going to bounce off to 0. Okay? Number 3. Okay, this one's x cubed. So how many zeros am I going to look for? 3, right? This won't factor. There's no factors of 32 that give me 6. So I'm going to do my calculator again. So x cubed minus 6x squared plus 32. Straight through, and it bounced. All right. So I'm going to go to, let me move this over so you can see it. Looks like negative 2 and 1, 2, 3, 4. Again, what do I look at to make sure? Second graph table, right? Negative 2 and 4. Okay, so what's going to happen here since it bounced? What's the multiplicity? 2. You don't have to show it to me through synthetic division. You guys should know that it's going to be 2. All right, so that's the answer. Negative 2 and 4. Make sure you tell me 4 works twice. Any questions on that one? Making sense? If that's how you did it, yeah, just do a little sketch of it. Good question. So if you do it graphically, just do a little sketch of your graph, and then, you can label it like I did. That's negative 2, that's a 4, and then put times 2. You don't have to show me the the table, I just was showing you to help you out. You don't have to show the table. Any other questions? Yes, Kim.
So, I'm just like, confused about like, there's only like 2 zeros on.
Well, there's 2 that you can see, but since that works twice, you count it twice, so 1, 2, 3, and that's how many it should be. Okay? So multiplicity, when you count it, you count it that many times and whatever else, so when you add them up, you get the original degree. Okay, so that gives us the 3, right?
Yeah.
Okay. Good question. Any other questions? No, we're taking it tomorrow. 24, yeah. And this last one's the easiest one, right? You don't even need to use your calculator for number 4. The answer is right in front of you, right? So this one we have x plus 2 squared and x minus 7 cubed, all right? So to find the zeros, you just write x plus 2 equals 0 and x minus 7 equals 0. Most of you don't even need to do this part. You know this one is positive 7 and you know this one's negative 2, right? But there's multiplicity. What's the multiplicity of the negative 2? Yeah, whatever the exponent is. So just put a little 2x under it. And what's this multiplicity? 3. Just put a little 3x. You don't have to tell me, like we did last week, you told me it balances and crosses. You don't have to tell me that tomorrow. I want you to tell me how many times it worked. Okay? So, number 4 will take you 30 seconds, right? Cameron?
Like, going back to like number 2,
Mhm.
because it was like x to the 4th, so how many times did you have to find that? And you just find it with the graphing?
You can if you want, graphing, yeah. Now, these won't be in the table. You guys know how to find these without the table on the calculator. Yeah. Second trace and look for 0. Do you want me to go through that again? I can.
Yeah.
All right. So put this one in your calculator. We got time. Number 2. I didn't do it. I did it without the calculator, that one. Okay? But with the calculator, all right, it's x to the 4th minus 3x to the 3rd minus 3x squared. Okay? And then graph it. And it bent. See how it kind of bent as it went through there? Or maybe not. Maybe it bounced. Right? So it's hard to tell right there what's going on, right? So let me show you a little trick here. I'm going to hit, well, first of all, let's go to the table. One of the zeros is 0, right? The other ones you can't see. But you know it's between -1 and 0 and between 3 and 4 by looking at it. Okay? Do I have 3 and 4? Yeah. 3 was -27, 4 was 16, so you know there's a 0 between because one answer was negative, one answer was positive, right? Between between 0 and -1, all right? So hit second trace and 0, number 2, and left bound means you gotta get left of it. So I'm above it, okay? Hit enter, and then right bound, you gotta get below it. which it is, I can tell it's below because that y value is negative 0.27. And then guess, there's a negative 0.8, that's this one. Or if you want to use negative 0.79, that's okay too. Okay? We know that one's 0. Okay? It's kind of hard to tell that it bounces off the 0 because it's so small there. Let me get this 0 over here, the 3.8, and then I'll show you something to look at this a little better. So second trace, 0 again. And now left of this one would be below it. Okay, so that's above it. That would be right of it. So I got to go down. I can't see it. It's a negative 10. I hit enter. Right of it's above it. Enter. And then guess. And there's our 3.8. Okay? We okay with left bound and right bound? Okay. Because it's kind of hard to tell that it's bouncing off, if you hit zoom box, so the zoom is right there next to trace up in the middle. I like to do the box. I like to draw a box around the area I want to zoom in on. So when I hit enter, my cursor, or because I've been moving around, is over here, but I'm going to move it over. All right, to about there, and hit enter. And then as I go left, it'll start drawing a line. That's the top of my box. So I'm going to get both of these zeros in the box. And then I'll go down, and there it starts drawing the box. Okay, so when I hit enter now, it's going to just zoom in on that area. And then you'll be able to see what happens better. There's the negative 1. There it goes up to 0. So you see it bounces off at 0. Okay, so if you get something like that tomorrow where it's kind of crunched together, draw a box around it. It's Z box. Okay, and then you can see that it crosses here, and then it bounced off of 0, so that worked twice. That 0 worked twice is what we figured out when we did it by hand. Okay? Any other questions? No, I did it. All right, that's it.